Okay, so we started the third topic in P1, which is sequences and series, and we discussed what a sequence is. So I'm not going to do that again. We just started writing the note. So we'll start from there. Uh, can Umasha was in the class last week. Umasha, up to what did we write? So we wrote a sequence or a progression is a set of numbers in a given order that may or may not follow a pattern. We talked a lot about this. And then we said a sequence can be finite or infinite. Did we write, is that all we wrote, Umasha?
Yes, ma'am.
That's right, that's all, no? Okay. I think this is not working. Okay, then one more sentence to that paragraph. This is just an introduction to what a sequence is. The last, so Senitu, you weren't here last time, right? I think, if I remember right. So we've just written two sentences, and then the last sentence in that paragraph, you write it. The numbers in a sequence, the numbers in a sequence, the numbers in a sequence are called, the numbers in a sequence are called, in red, terms, terms. You are familiar with these things already. So we say the first term, the second term, the third term, and so on. So each number in your sequence has a position. They are in a certain order. That's the thing about sequences. It's a set of numbers that are in a certain order. There might not be a pattern, but it's true that we are interested in sequences that go according to a certain pattern. Now you will see that we are going to learn two types of sequences, and both of these types go in a certain pattern, right? When they go in a certain pattern, we can make calculations about the sequence. For example, we can find a certain term that we want. If we know how the pattern goes, we can find a certain term that we want, and we can find the sum of terms. That's what a series is. We can find the total, the summation of a certain number of terms in your sequence, and so on. So these numbers in your sequence are called terms, terms in red. And another thing, a sequence does not always just mean a sequence of numbers. It can be anything, but we are learning only about sequences where the terms are numbers, okay? Right, so let's write down a few examples, and let me know how the IV cam is working today, whether it's clear enough for you. So you had that small paragraph, and then you write examples. I'll show you two examples of sequences. Here's one. Oh, so we said that a sequence can be finite or infinite. Finite or infinite. A finite sequence means there is an end to the sequence. It stops somewhere. There is a last term. An infinite sequence, on the other hand, is a sequence that goes on forever. There is no last term. It goes on and on and on. It's infinite. Okay? So you could have a finite sequence with a certain number of terms, or you can have an infinite sequence. So here is an example. Very simple sequence: 1, 3, 5, 7, if I put ... that means it's an infinite sequence. These three dots, it's called an ellipsis. It means it goes on forever. It's an infinite sequence. So here's your first term. Here's your second term, and so on, right? So these are terms. So each term has a position in the sequence. So this can't be somewhere else. It's in this order. 3 is the second term. Here's another example. And you can see that this goes according to a certain pattern. There is a pattern. When there is a pattern, you can predict what the next term is going to be. Here's another one. Half, quarter, 1/8, 1/16, dot, dot, dot. Again, it's a sequence, and it also has a pattern. If you want, you can say what the next term is. And again, here's your first term, here's your second term, and so on. First term, second term, and so on. Third term and fourth term, and so on, right? So copy that, the two examples. Okay, and then let's introduce the term series. So these are sequences, a line of numbers, that's it. What a series is, students tend to confuse between these two terms, okay? So you have to be very clear as to what a sequence is and what a series is. A series, then the word series is given to the sum of a certain number of terms in your sequence. So it can be it can be the sum of the first 10 terms, or it can be the sum of all the terms. If it is a finite sequence with say 100 terms, you can find the sum of all 100 terms. Or if it is an infinite sequence, you can find we'll discuss about that. Is it possible, if there are infinitely many terms, is it possible to find the sum of all of them when it goes on forever? Can we even find the sum of all of them? So that's something to think about. But if you take the sum of terms of a sequence, that sum is called a series. So the word series tends to give us the feeling that that also is something that, you know, like something like a sequence, but it's just one number. Series is the total, the sum, okay, of the terms of a sequence. So it could be a certain finite number or all of them, infinitely of them. Okay, so let's write that. A new paragraph after these examples. Please ask anything if you have anything to ask. So new paragraph. A series is, write series in red. A series is a series is a series is the sum of terms. A series is the sum of terms of a sequence. It's a sum of terms of a sequence. Sum of terms of a sequence. Full stop. This sum can be of finite number of terms. This sum can be of, this sum can be of finite number of terms or infinite number of terms. Now, as you write that, you start thinking, can I add infinite number of numbers? Is that even possible? Think about that, okay? This sum can be of finite number of terms or infinite number of terms. Example for that. Under that example. So here's a series. For the same two sequences you had before, if I write the sum, so 1, if I take this first sequence and if I add the terms 1 plus 3 plus 5 plus 7 plus Suppose I add I add 1, 2, 3, 4. I add 5 terms. 1 plus 3 plus 5 plus 7 plus 9. I stop there. So this gives you, so this is a number, right? This is what a series is. It's the addition or the summation of a certain number of terms. So it could be finite. Or here's another example. If I say for the second sequence here, if I do half plus, quarter plus, 1/8 plus, 1/16 plus, and if I do dot, 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 that means I'm adding infinitely many terms of that sequence. I'm going to keep adding all the terms in that sequence, infinite terms, okay? So there would be an answer to this. That is what the series is. So this is how you write it expanded, like you're showing what you're adding, and that will yield a number. Here, do you think that will yield a number? Let's see later, okay? Whichever it is, this is what a series is. This is a series. Let me also say this. Strictly mathematically speaking, the word series is used if the summation is infinite. But for your level, we use the word series even if the number of terms that you are adding is a finite number. But strictly speaking, you have to use the word series only if you are adding all of them, like infinitely of them. Okay, so strictly speaking, this is what a series is. Okay.
Excuse me, miss.
Yes, Sakit, hi. When did you join?
I had a small power cut, miss, in the last moment.
Oh, did you
Now
just join?
came. Yes.
So you didn't miss much. We just continued writing the note, and we discussed what a series means. Um, so, Umasha, can you tell her like how many lines to leave us?
After the first examples, miss, 2 lines is enough.
So, Akit, if you just joined, the last thing you would have written is what we wrote last week, na? From there,
Yes.
Umasha?
After that, another one more line.
Uh, and the
Then
example?
first example. Then 2 or 3 lines.
Yeah, so
Again,
altogether
second.
maybe like half a page?
Not half, miss.
Not half.
Yeah.
Are you able to show your book?
Yes, yes.
Akitni, if you can.
Can you see, miss?
No.
Oh.
Senitu says around 18 lines in total. Okay.
Okay.
Okay, Akitni, leave about 18 lines in total. In total, under sequences and series, about 18 lines. You already have written 2 sentences from last week, and then another maybe 16 lines. Okay. Right. So is it clear what a sequence is and what a series is? A sequence is any line of numbers with a pattern or without a pattern. It doesn't matter. A series is the sum of these terms of a sequence. You can add up to a certain point in your sequence, or you can add, if it is a finite sequence, you can add all of them. Still, it is a finite number. Or if you have an infinite series, you still can add all of them, infinitely of them. That is called a series. So series is actually one number. It's the sum, right? But you can write it like that. So when you write it like that, it looks like that's why you call it a series. But now, if you find this sum, it's going to be just a number. Now you might wonder, why do we call a number a series? Because this represents the sum of these terms. Okay, right. So as I told you in the beginning, there are so many different kinds of sequences and sequences, and then series is just the sum of the terms of a sequence. There are different kinds of sequences. We are going to learn 2 very basic types of sequences. Okay, I'm sure you have heard of this already. I think you may have learned this also in O level. They are called arithmetic sequences and what? Do you know? So these two go together, arithmetic sequences and what's the other one? Have you not learned this before? Geometric, yes, Sanita. Okay, arithmetic sequences and geometric sequences. And then when you add their terms, you can say arithmetic series and a geometric series. Okay, so this is what we are going to be learning in this topic. So write in a new line, we will learn about two basic types of sequences. We will learn about two basic types of sequences. Two basic types of sequences. Number one, arithmetic. Number two, geometric. And you will also realize, now we will see what they are. Let us write arithmetic sequences and geometric sequences and their corresponding series. Then you will have arithmetic series and geometric series. If you add the terms of an arithmetic sequence, you call it an arithmetic series. If you add the terms of a geometric sequence, you call it a geometric series, right? You will realize why they are given these names, arithmetic and geometric. Arithmetic means to do with like numbers. Why do we call it arithmetic? Why the other one is called geometric? So you will see why that is. Okay, so let's start. Before we start learning about these two, there is a certain set of symbols that you have to know that we use as notations in under sequences and series. Okay, so write a little subtopic, notations. So this is common to both types. Whenever you learn about any sequence, these are the standard notations used. So notations. Okay. Here's the first one. When you want to refer to a certain term in your sequence, say the 10th term or the 20th term or the first term or the 129th term. So in general, we say the nth term, where n can be any number, right? When you want to refer to a certain term in your sequence, if the number is n, nth term, I'll write it like that, nth. So fifth, n can be, if n is 5, it's the fifth term. If it is 7, if n is 7, seventh term. So when you want to refer to the nth term of a sequence, we have a notation for it. When I want to say 10th term is this, we don't write 10th term in words. There is a symbol for it. Nth term is denoted by U and a little subscript n here. So U is like the term and n is the position of the term. So for example, if you want to refer to the fifth term, U5, 10th term, U10, and so on, right? So nth term is UN. That's the notation for nth term. And then if you want to call, like, for example, if you want to say the first term of a sequence, you might tell me, why are we even writing that? So first term would be U1, isn't it? U1. But there is another special notation for the first term. You can of course use U1, no problem. But sometimes you will see, even in your book, they also use A for the first term, because the first term is special, right? It's the first term. So we give a special symbol for the first term, A. Or you can throw the A away and just say U1. So U1, U2, U3, U4, and so on. These are your terms. First term, second term, third term, and so on, right? Then, when you want to say when you want to talk about the sum of, say, n number of terms, sum of n number of terms. So you're talking about a series now, sum of n number of terms in your sequence. Say if I want to refer to the sum of 10 terms, then the notation is S subscript n, Sn. So if I say S10, that means sum of 10. So you always begin with the first term. You don't take like in the middle from the first term up to a certain point. So S10 means the first 10 terms. S100 means the sum of the first 100 terms. Okay. So Sn, if you see this in somewhere, you have to know, like if you see, for example, if you see, so I could have written here an example like U, if I say U5, that means the fifth term. If I say S10, that means the sum of 10 terms, right? Sum of 10 terms. Then we also have, if we are adding the terms of an infinite series, that means we would get the sum of infinite number of terms, infinite number of terms. Okay. Now you must start wondering whether this is even possible. What are you talking? What do you mean infinite? So if the numbers go on forever, so think of a sequence. Think of the sequence 1, 2, 3, 4, 5, 6. 1, 1, 2, 3, 4, 5. Okay, it's an infinite sequence. Does it have an end? No. So can you add all these numbers? Would you get an answer? Think about that. Is it possible to add all of them? Right? Think about that. So sum of infinite number of terms of a certain sequence is denoted by, sorry about the noises, S infinity, subscript, S infinity, right? So these are the basic notations. U is used for term with a subscript to say the position of the term, U1, U2, U3, and S for the sum, okay? Right, now let's start looking at what an arithmetic and a geometric sequence is. Here I want you to do, now I hope, do you all use like a big CR book like this to write your notes, or anyone using a small book? Because the way I'm going to do this is, I'm going to ask you to divide your page into two, right? And we are going to learn about these two types side by side, parallel, because I think it's an effective way of learning about these two sequences, because then you can see the comparison, how they differ, what are their similarities, how different formulas that come under each type make sense. That becomes visible, and you might understand it better when you do it together. This is not the usual way. CR book. Okay, great. Then I think it's wide enough. That's the only concern I have. When you divide it into two, you will have only a little width to write everything. So try to manage. So this is a heads up. So try to manage, write small letters. This is not the way that anyone would do it usually. I don't think anyone does it like that. You would usually, for example, now when you learn this in school, you will see, you will learn about arithmetic sequences and series. You finish it off, and then you go to geometric. That's how you do it. But I'm going to do it together. Okay, each step for each one. When we talk about a certain thing about arithmetic sequences, we will also talk about the same thing in geometric sequences. So it will build up together. Okay, I think that is, yes.
Teaching the same page we have to divide.
Can you if you can, yes, of course, Umasha. Was it Umasha Akitmi? Who asked that? Akitmi, yes. That's a great suggestion. If you can do it on a page like side by side, that would be great. Yeah, so you start on a new page. So yeah. Good idea, Akitmi. So you start on a new page, right? So arithmetic, geometric. Okay, let's do it like that. Nice. So start on a new page. So page like this. Great. So I will do it by dividing this into 2. So you can nicely spread out everything and use the space and write. So I will just split this into 2. Or I can use 2 paper. No, no, I will do it like this. So I will be writing very small letters. Okay. So on top of each, so for you on your top of your pages, on top you write, this is all to do with arithmetic. So we are looking at arithmetic sequences and series. So you just put arithmetic, and here geometric. Okay. Then under the 2 topics, your first sub, so they go the same way. That's a nice thing about it. So that's why it's beneficial to do it side by side. You get the understanding in a systematic way about both of them at the same time. That's nice. So first subtopic, arithmetic sequence. So I'll write here arithmetic sequence. We'll see what an arithmetic sequence is. An arithmetic sequence, and here we will see what a geometric sequence is. Remember, these are the most basic type of sequences, and they're very useful, and they pop up in all sorts of places. That's why you are learning about them. Geometric sequence. Okay. Does anyone know already what an arithmetic and a geometric sequence is? A sequence is said to be arithmetic if the numbers in your sequence go or follow a certain pattern. And what is the pattern? By the numbers progress by adding a fixed number. By adding a fixed number. Now I will write something here. You don't write that. This is just to explain. I'm writing it. What did I say? A sequence is called arithmetic if your numbers progress in the sequence by the addition of a fixed number. So for example, you start with a certain number. Say I start with 5, and I add a fixed number to it. Let's add 3 to it. Okay. 5 plus 3, I get the next term, 8. 8 plus 3, I add the same fixed number. So the number that you add each time is fixed. You don't change it. The same amount you add each time to get the numbers in your sequence, to get the terms in your sequence. 8 plus 3, 11. 11 plus 3, 14. Like that. So it goes on like that. So if you notice this pattern in a sequence, what is the pattern? The numbers progress by the addition of a certain fixed amount. So 5 plus 3 gives you this. 8 plus 3 gives you 11. 11 plus 3 gives you that. So if a sequence follows this characteristic, we call it an arithmetic sequence. And that fixed number that you add all the time, in this example, the 3, is called, does anyone know? Because another way of thinking about this is this. If you take the difference between any 2 adjacent numbers in your sequence, if it is arithmetic, the difference between any 2 adjacent terms would be the same. So the difference is common for any 2 adjacent terms. Yes, Senitu, common difference. Okay, so that fixed number that you add each time is called the common difference. And that makes sense why it is called common difference, because it's the difference between 2 adjacent terms, and it is common to any 2. Okay, so it's a common, the sequence has a common difference between any 2 terms. Then we call it an arithmetic sequence. Okay, so let's write that first. So under arithmetic sequence, you don't write this. You write what it is, a small 2-sentence paragraph, right? A sequence in which so Senithu is asking 2, 8, 18, 32, an arithmetic sequence. Is it? No, it's not. The only small thing that you have to check is whether check the difference between any two terms. Now, what's the difference between 2 and 8? Let's do 8 minus 2. It's 6. What is 18 minus 8? That's a difference. It's not the same. It is not an arithmetic sequence then. Okay, the only one condition there needs to be for a sequence to be an arithmetic sequence is any two adjacent terms must have the same difference. Yes, that's correct. That's what a geometric sequence is. I'll come to that. No, that is not even a geometric. It's not even a geometric. So it is a sequence and looks like there is a pattern. I'm not very sure whether there is a pattern, but it's a sequence. Now, you know what a sequence is? Any line of numbers with or without a pattern. So that is a sequence, but it's neither an arithmetic nor a geometric. So we will come to that, what a geometric is, okay? Right, so write under arithmetic sequence, a sequence in which the numbers progress, a sequence in which the numbers progress by the addition of a fixed number. Addition in red, fixed number in red. A sequence in which the numbers progress by the addition of a fixed number is called an arithmetic sequence. Arithmetic sequence in red. A sequence in which the numbers progress by the addition of a fixed number is called an arithmetic sequence. Okay. This fixed number is called the common difference. Common difference in red. This fixed number is called the common difference. Common difference in red, and within brackets, so you wrote common difference. Within brackets, the notation for common difference is simple D comes from the letter D here, right? Simple D is the symbol used to denote common difference, D. Let's write a few examples. Here's an example for an arithmetic sequence. 5, 8, this is the same thing I took, 11, 14. You show on top how they, so from here to here, you add. So you're adding a number each time. Add what here? Add 3. From here to here, add 3. From here to here, add 3. Right? So what's D for this sequence? Now it goes on, right? What is D for this sequence? D is 3. Here's another example. 10, 5, 0, -5, dot, dot. Is it an arithmetic sequence? Let's see. What do I have to add to 10 to get 5? Add a -5, add a -5. That's right, Senator. Add a -5. Then add a -5 to 5, you get 0. Add a negative 5 to 0, you get negative 5. So this is an arithmetic sequence, and the D for this sequence is negative 5. So your common difference could be a negative number. If it's a negative number, what that means is your numbers go down, right? They decrease. If your common difference is positive, your numbers increase. You're adding a positive number each time, your numbers grow. If the common difference is negative, your numbers get smaller and smaller, right? And here's a nice little formula, and this is not magic. If I want to write like a formula for D, if when I give you a sequence, an arithmetic sequence, the easiest way to find what D is, you take any term and you minus the previous term. You get the common difference, isn't it? Any term minus the previous term gives you the common difference. It's like a little formula. I mean, that is not, you can't even call it a formula, but yeah. So if I give you a sequence, if you want to check whether it is arithmetic, take any two adjacent terms, take one term, minus the previous, see whether you get the same answer if you do to a different two terms. Okay? Is it clear up to there?
Yes, teacher.
Right, okay. Now let's say that same amount that we learned about arithmetic, let's go and see for a geometric sequence. Let's see what a geometric sequence is and how the terms or the numbers in a geometric sequence progress, okay? Now, by now, I have a feeling that you may have guessed. So in an arithmetic sequence, the numbers progress by adding a fixed number. In a geometric series, the numbers progress by, so you start with a certain number, say 5, I start with the same number. You get the next term by multiplying this by a fixed number. Here you added a fixed number, here you multiply by a fixed number. So say, let's keep multiplying by 2. So 5 times 2 is 10. 10 times 2 is 20. 20 times 2 is 40. Notice that I'm multiplying by the same number, fixed number. Okay. So how do these progress here? Times 2 gives you that. Times 2, don't write this, I'm just explaining. Times 2 gives you that. Times 2 gives you that. And so on. That is called a geometric sequence. So a sequence is called a geometric sequence if the numbers progress by the multiplication of a fixed constant number, right? And that fixed number that you're multiplying your terms each time to get the next term is called, so common ratio. Why is it called common ratio? Because if you take any two, now here if you take any two adjacent terms, any two, this and this, or this and this, or this and this, any two adjacent terms, if you take this and this, the difference between them is the same for all. So 14 minus 11 is the same as 11 minus 8, is the same as 8 minus 5. So the difference between any two terms is common. Here, the ratio between any two terms is common. That means you take any term and divide by the previous. 10 divided by 5 is 2. 20 divided by 10 is 2. 40 divided by 20 is 2. The ratio between any two adjacent terms is the same. Then it's a geometric sequence. And that fixed number is called common. Why do we put the word common? Because it's common between any two adjacent terms. And it's a common what? It's a common ratio. It's a common ratio. Guess what the symbol is for common ratio? What's the symbol? R. Simple R, from to denote ratio, R. So common difference is D, common ratio is R. Okay, so let's write that first. So parallel to what you wrote for arithmetic, now you can, I mean, the beauty of this is this. You can fill the other side up now. You can write a similar little 2 sentences that I gave you under arithmetic. You can now write your own 2 sentences corresponding to geometric. So it would go like what? A sequence in which the numbers progress by the multiplication of a fixed number is called a geometric sequence. And this fixed number is called the common ratio, within brackets R, common ratio in red. And let's add 2 examples again, just like we wrote 2 examples here for arithmetic. Let's write that itself. So I'm starting with the same first term. I'm starting with the same first term, 5, comma, 10, comma, 20, comma, and so on, dot, dot, dot. What's happening here? From here to here, sorry, I'm using black. You can say, let's put the multiplication sign. It's multiply is a too long word to write there. Multiply by 2. Multiply by 2. Let's show another one. Multiply by 2 and 40. So that means comma dot dot dot. It's going on forever. It's an infinite sequence. What I have written here. Or for this geometric sequence is 2. R is 2. Here's another example. So copy the examples. Here's another one. I start with 1. Next one is half. Next one is quarter. Next one is 1/8, and so on. What's the common difference here? Sorry, what's the common ratio here? There is no common difference here. It's not an arithmetic sequence. It's a geometric sequence. What's going on here? Every term is being multiplied by what?
Half.
Half. 1 times half. So it's like it's been divided by 2. The term is divided by 2. It's same as saying multiplied by half. So times what? That's what you have to think. Times what number? Times half. Sorry, half. Times half. So the common ratio for that is half. And in the same way, you wrote a little formula for D for an arithmetic sequence. You can come up with a little formula for R. If I give you a geometric sequence and you want to find what the common ratio is, what you simply have to do is take any term and divide by the previous term. Here you take any term and minus the previous term. Here you take any term and divide by the previous term. You take any term. Why can you take any term? Because it's the same. It's a common ratio. The same ratio between any 2 terms. So you take any term and divide by the previous term. Okay. Yes, Senitu, I'm just seeing your response now, 0.5. Yes, that's same as half. That's correct. Okay. So that's the intro for an arithmetic sequence and a geometric sequence, right? Let's go into the next subtopic under each, okay? All to do with arithmetic here, all to do with geometric here. So for an arithmetic sequence, let's discuss, there is a formula for the nth term. There is a formula that we can use to find any term we want down the sequence if we know certain information. So we are going to learn that. So your little topic parallel to arithmetic sequence, parallel to this, okay? Your next topic in that column or in that page. Nth term of an arithmetic sequence. I'm going to write AS in for short because I don't have a lot of space here. Nth term of an arithmetic sequence. At the same time, you can write on the other side, nth term of a geometric sequence. But we will talk about that after we do this. Nth term of a geometric sequence. Okay, this is a cool thing that we are going to do now. You will see that you are the one who will be deriving this formula. It's a formula, but you will derive it. See what I'm going to do. So I'm going to write out an arithmetic sequence in general. I'm not taking a particular example like this. I will write using notation, a general one. So, for example, think of an arithmetic sequence. Now, according to our notation, the first term is denoted by, shall I use the notation A? Okay, so I'm starting with the number A. That's my first term. Okay, let me write on top. So what I'm considering an arithmetic, I'm considering an arithmetic sequence whose first term is A, and the common difference is D. I'm using notations, okay? Don't write, I'm just explaining. You can write later. So I'm thinking of an arithmetic sequence. It's in general, right? I'm not taking a specific example. I'm talking in general. So let the first term be A. If the common difference is D, what's going to be my second term? Can I write it using A and D? I start with A. My second term would be, the common difference is D. Yes, Senitu, A plus a D. Is that right? A plus D. You add a D to it. Remember how we did that? Add 3, add -5, you add your common difference. So my second term I can write as A plus D. So let me write also here. This is my first term. This is my second term. Can you tell me what my third term would be? Can I still write only in terms of A and D what my third term is? I need to add another D to this, isn't it? I have to add another D to this. Yes, Senitu. So A plus D plus D. That would give me A plus 2D. That's correct. Now, to get to the third term, I have to add 2 Ds, right? So that's good. A plus 2D would be the third term, right? I hope you can already see something going on here. Can you also tell me one more? What's the fourth term? What's the fourth term? A plus 3D. A plus 3D. A plus D, A plus 2D, A plus 3D, A plus 4D, and so on. Who can tell me? Now I'm going to use the whole thing without the, so ignore this. So I'm going to put some dots. If I want to write, sorry, in what color? In this color. If I want to write the 100th term, that would be what?
A plus 99D.
Very good. A plus, because A is the first term, and to get to the 100th term, you need to add 99 Ds. So A plus 99D would be the 100th term. Now, can you tell me? I go some more. And if I call a certain general term, if this is my nth term, where n could be anything, what would be the nth term? Very good, Sanitu. Now, I want to ask you, have you learned this before?
Yes, teacher.
You have, right? In O-levels. You had this in your O-levels. Huh?
Teacher, A levels.
Ah, you already learned this in school. Huh? Okay, already learned in school. Nah? Has school done a lot by now? A plus n minus 1D. Now, what I want to happen here is this. You should never memorize this as a formula. Now, this leads us to the formula for the nth term of an arithmetic sequence. So you can say un, that's the nth term, is equal to a plus n minus 1 times d. I just want you to see that how it is derived, why it makes sense. Okay. So now this is all under this first column for you on your first page. So okay, let's write then. Okay, let me first say it here. No, let's write up to that. Okay. So under nth term of an arithmetic sequence, you write a sentence. Let's think of any arithmetic sequence. Let's think of any arithmetic sequence. Let's think of any arithmetic sequence with first term A in red, with first term A in red, and common difference D in red. Let's think of any arithmetic sequence with first term A and common difference D. Then you copy this. So I have written all of these terms. I can write any term I want only in terms of the first term and the common difference. That means that's all I need to know. I can tell you whatever the term that you want me to tell you, right? If you ask me for the, can you tell me the 2059th term? I can tell you. Well, you have to know two pieces of information, the first term and the common difference. So you copy that. And then that gives you the formula for the nth term.
Excuse me, miss.
Yes, Umasha?
Can that A plus 99D, can that be a geometric sequence? Because in geometric sequence, that should be multiplied. No?
Yeah, so we haven't multiplied, we are adding. To the first term, a certain number has been added 99 times. Any multiplication going on here? Do you mean the 99D, that multiplication? This only means you have added D 99 times. You have to keep adding 9, sorry, not 9, add D 99 times because you have gotten to the 100th term. Because each time you have to add in an arithmetic sequence, each time you add a number, same number you add. So if you add the same number twice, I can say 2. You add 2 of that. If you have to add it 5 times to get to the 6th term, you add 5 of that. So it's not geometric. You're adding here, adding. The addition is here. This is the addition here. Adding. It's an addition of a constant, and that constant
Okay.
is d. Did you understand, Umasha?
Yes, yes.
Yes. Okay. Senitu, if we do not know either a or d, but a different term in a sequence, can we find find another term if its n is given, um, but a different term. Give me an example, Senitu. What what are you exactly asking? I'm not very. It's not very clear to me. You have to know A and D. Now they might give you different information. You have to, using those information, you have to find A and D in order to find some term that you want, nth term. So this is the formula. To get the nth term of an arithmetic sequence. Okay, something like 357 is given, find you 100. 3 is not A, then you can't find. If you don't know the first term, you can't find the 100th term. So if you say your sequence is 3, 5, 7, 3 is the first term. Do you mean to say that you have given a certain section in the middle of a sequence, you don't know where it has started? Then you can't find. You have to know the first term and the common difference. Otherwise you can't. Just think about it. How can you find? Now say, if you knew which term 3 is, I think that's a good problem to think about. Now, if you have finished copying this is what Senitu is saying. You are given that there is this sequence 3. This is a certain section of a sequence. This is not the first term, but say you are given that this is the fifth term or something. Okay, and on fifth term onwards, a couple of terms are given, 3, 5, 7. Can you find U100? This is what Senitu is asking. Now you will see that. But what do you think? You have to figure out the first term, or indirectly you would be doing. You can do like this. If this is the fifth term, let me not say it. Can you think how you can? This can be tackled. This can be done.
Teacher,
Yes, Akitmi.
you get like a plus 4d is equals to 3 and a plus 99d is equals to...
Okay, let me write. So Akitmi is saying, we know the fifth term. So U5, we know U5. U5 is 3. So I can say 3 is equal to a plus 2d. Then I can easily find D. I have adjacent terms. What is D here? D can be quickly found. D is 5 minus 3, D is 2. And then you have to think about this and figure out A. So A is A plus 2D. D is 2. 2 times 2 is 4. A is, sorry, I'm running out of space here. A is 3 minus 4 minus 1. Right? So you have to find A. Here's A, here's D. Then you can find U100.
Teacher, is it a plus 4d, right?
Sorry, 4D. Yes, it's the fifth term, 4D. So that is 4 times 2, 8. 3 minus 8 is minus 7. Sorry, 3 minus 8 is minus 5. It's not clear what I'm writing here. I'm sorry about it. Let me write it somewhere here. I don't have space. Yeah. A equals minus 5. So you can use that and this D is equal to 2 to find 100. That's Senitu, what you have written is correct. Yeah, so this is how you would be given questions in the exam paper. You won't directly be given, here's your A, here's your D, find U100. that no fun in that, isn't it? You just have to plug into this formula. You will be given problems like this. That is exactly what they do. Like, so you have to find A first and then apply that to find U100, right? So that was a good question, Senitu. Okay, have you all written up to here? Did you get up to there?
Teacher till UN, right? Are they
Up till here, yes, up to here. Now this was the explanation for Senithu's question. Up to here, nth term of an arithmetic sequence un is equal to a plus n minus 1 times d. So that's your first. That's actually your second formula. If you count this also to be one formula here, let's highlight them. Under arithmetic, you have those two formulas now. You have a formula to find D. You have a formula to find any term you want, nth term. So to find the nth term, you need A and D. If you're finding U100, you have to have A and D, and then here 99. Okay, now let's do the same thing for geometric. So I'm going to the other column, nth term of a geometric sequence. I will do it on a new, but I will keep this like that for the comparison. Okay. So here's now this is in the geometric column, and under nth term, oops, sorry about that, nth term of a geometric series. This is on the other side. Nth term of a geometric series. Now you can develop this little note. We are going to derive a formula how to find the nth term of a geometric series. So let's take a general geometric series whose first term is A and the common ratio is R. Let's start the same way we did. So let's write and do it. Let's think of any geometric sequence right under this. Let's think of any geometric sequence with first term A. No problem, Senithu. Sorry for in the question I asked before, if we knew the value of U100, if you knew the value of U100, then what are we asked to find? Yes, okay. So another variation of a problem. Yes, now you will see many problems like this. When we now let us complete up to this UN formula for geometric, and we will look at a couple of questions. You will see this is the type of question that you get to solve. Yes, Senithu. So you can be given two terms, like the fifth term is given, the 100th term is given. Then you can write two equations for the two. There will be two unknowns A and D. But then in your problem, Senithu, D can be already figured out because you gave 3, 5, 7, right? So you don't need two simultaneous equations. You can find D and then you can find A. But I can see what you are getting at. Yes, there can be questions like where you are given, you are told fifth term of an arithmetic sequence is 10. 100th term of the same sequence is 297, something like that. They give you some two terms along your in your sequence down the line. Find the first term and the common difference. If they said that, you have to write the nth term for the two terms that you know and solve them simultaneously. Yes. Okay, so we'll look at problems after we complete this. Okay, so we are writing under nth term of a geometric sequence. Let's think of any geometric sequence with first term A in red, and common ratio R in red. first term a and common ratio r. So just like before, if I try to write this sequence out, I know the first term is a. Okay, this is the first term. How do I write the second term? If the common ratio is r, this is a geometric very good. I have to multiply a. Earlier I added d. I added d in arithmetic. Here I have to multiply this first term by r. So it will be a times r, which I can write as ar. ar, right? That's my second term. Write with me. Let's do it together. Second term. What would be my third term? Can you write the third term? For the third term, I take the second term and multiply that by r again. So ar times r. What is ar times r? Ar squared. Very good. Please make sure you understand what we are doing, right? You start with a times r gives you this. This times r again would give you ar squared. Ar squared. So ar times r. Let's write one more. Write the fourth term. We do it just until we see the pattern. What's going on here? Fourth term, you take the third term and multiply by another r. So ar squared times r.
AR cube.
Ar cube. Then dot dot dot. If I have my 100th term here, what would be my 100th term? A should be multiplied by r how many times to get to the 100th term? 99 times. So that means a r to the power of 99. So notice here, Umasha, I think earlier had that doubt. Here a is being multiplied. Earlier something was added to a. So that's arithmetic. This is geometric. That's why you have multiplied a by something each time. And then you can now think of, what if I want the nth term? How would that go? If this is the nth term, nth, where n can be any number I want, would be a r to the power of n minus 1. So if this is 100, power is 99. If we want the nth term, power must be n minus 1 power. So that gives you a way to write a formula for the nth term of a geometric sequence. So let's write it. Nth term of a not series, geometric sequence. You have to excuse me if I, by mistake, this happens. If I use the word series when I mean sequence, okay? I have a couple of pairs of words like that I get confused between. One famous one that happens to me all the time is left and right. I don't know what left and right are. And I get confused between push and pull. And sometimes I show the vertical axis and I say x-axis, where this is the y-axis, okay? Yeah. So you should know what I mean if I make a mistake like that, okay? Nth term of a geometric sequence, un is given by the formula a r to the power of n minus 1. Okay. Now I have to do a small as I told you, I'm using somebody else's laptop, my brother's laptop. So I wanted to do, how do I do that? I can show. I wanted to do, so you don't have the book sequences and series booklet. I will show you that. Um, so you have to get it. It's this. We will try a couple. Now this note has to continue. Shall we complete the whole thing and then look at some questions? Now we have to also now discuss series, how to find sum of n number of terms, how to find Sn for an arithmetic, for a geometric. And then can we find S infinity for an arithmetic and for a geometric, okay? And then if we finish up to there, that would be it for this sequences and series part. And then you have the binomial theorem. The reason why I want for it to go that way is because now if we disturb the note and do a question, that flow will be ruined, isn't it? Okay, if you can do the questions, if you can leave one more page would be enough. Like how much of your page is over by now? Like you started on a fresh page. Have you gone, is one whole page over by now?
No, teacher.
Not
I
yet,
have
right?
a quarter left.
You have about quarter left. Okay. Then another one page would be enough to complete the whole note for both of them. So you leave that and let's try a few questions only up to what we have learned so far. Okay. Only from this UN formula. But then the other thing is this. Now if I show you some, okay, I can show you the book also, right? This is how the book looks like. Right. Let me see whether I can find a question that only uses this formula without the sum, the series formula. And no, all of your questions has something to do with the sum also. Okay. So in school, did you do the exercises in the book, the questions in the textbook? Shall we finish the whole note up till series, up till S?
So, teacher, we can do the questions at home if you send them.
Yeah, that too can be done. So shall we finish the note first? Shall we finish discussing the theory part first? And
okay.
Yeah, right. Okay. So, but then it will be quite a lot to handle at once, but we'll take it slow. Okay, and then we'll take up questions at the end of the whole thing. Okay. So now if you look at the two notes that you have side by side, we have learned what an arithmetic sequence is, what a geometric sequence is. Here you have something called the common difference. Here you have something called the common ratio. These go by addition, these go by multiplication. Then we just did, we derived a formula to find any term we want in the sequence. If we know the first term and the common difference here, the first term and the common ratio here, okay? Next little topic under your, so coming back to, I will again divide my page into two and continue. Okay, so here's my arithmetic column. I think arithmetic ME or MA. Here's my geometric.
Teacher, I wrote with the E.
Yeah, it's E, right?
I'm not sure though, miss.
I think.
It's E, miss. In the textbook also it's given E.
A. Okay.
E.
E. Okay. Okay, it means E. Arithmetic. It's like mathematics and E. Right. Okay. Under arithmetic, your next, this will be your third little topic under arithmetic column. Let's put a little topic. Why arithmetic? I'm trying to tell you where this name came from. Did you ever wonder? Arithmetic and geometry? I mean, why would you call that geometric? What does it have anything to do with geometry? Did you ever think of that? So let's write a little topic. Why arithmetic? I'm talking about the name. Why are they called arithmetic? And here, why are these called geometric? Okay. Why are they called by that name? No, Senitu. So you thought you think there were two mathematicians by the name Arithmetic, Mr. Arithmetic and Mr. Geometric? No, arithmetic and geometry are the names of two branches of mathematics, isn't it? In arithmetic, you learn everything to do with numbers. In geometric, you learn everything to do with shapes. So these are not the names of people. These are names of two branches of math. So let's see why they are called, why they are given these two names, okay? It's because these two sequences have something very interesting going on. If you look closely at any three adjacent terms, here's what happens, okay? Let's write under arithmetic. There is an interesting relationship. There is an interesting relationship among any consecutive three terms. There is an interesting relationship among any three consecutive terms. Any three consecutive terms of an arithmetic sequence. Okay, so you take any arithmetic sequence, and if you look at any three, doesn't matter where it is, in the beginning, in the middle, towards the end, doesn't matter. Any three consecutive terms. So let these three terms be A, comma, B, comma, C. I'm just taking ABC, let us ABC. Okay. The relationship is this. Now you can go back, and we have written a couple of examples for arithmetic. You go and check whether this is true. For any arithmetic sequence, if you take three terms, okay, the middle term out of the three is the mean average of the two on either side, of the other two on either side. So this average is called arithmetic mean. That's the proper name in mathematics given to the mean of two numbers. It's called the arithmetic mean, because there is another mean called geometric mean. So this B is equal to, the middle term is equal to the average of these two. How do you find the average of two numbers? You add them and divide by 2, isn't it? This is true for any arithmetic sequence. You go back and check. Let's look at, so for example, here's one arithmetic sequence we wrote before. Let's take these three. Take any three. Now here's my middle term. Find the average of 5 and 11. Find the average of 5 and 11. 5 plus 11 is 16. Divided by 2 is 8. 8. Take these three. Okay, here's the middle. Find the average of these two. 8 plus 14 is 22. Divided by 2 is 11. Do it for a different one. Let's do it for this. Let's take these three. Here's the middle. What's the average of these two? 5 minus 5 divided by 2 is 0. Okay. This is why they are called arithmetic sequence, because they have something to do with, these terms have a hidden relationship. that it has something to do with the arithmetic mean of numbers. Okay, so now you wrote there is an interesting relationship among any three consecutive terms of an arithmetic sequence. Then you write ABC, and then you say B. You write a sentence before you write this. B is the arithmetic mean. Arithmetic mean. Mean means average. Mean of A and C. Of A and C. Of A and C. That means B is equal to. So this is true for any three. Okay. B is A plus C divided by 2. You take any term that is equal to the two terms on either side of that term, the sum of them divided by 2. That is the arithmetic mean of these two. The mean of these two. It's called the arithmetic mean. That's why it's called arithmetic. Then a similar relationship is there here. If you take any three consecutive terms, can you guess? It's called geometric mean. I don't know whether you know that. Have you heard of that before? This middle term again, the middle term is the geometric mean of these two terms. Geometric mean means here the arithmetic mean is you add the numbers. If you add 2 numbers, you add them and divide by 2. If you add 3 numbers, you add them and divide by 3. If you add 5 numbers, you add all 5 and divide by 5. That is arithmetic mean. Geometric mean means if you want to find geometric mean of 2 numbers, you multiply them and take the square root of that. If you want to find the geometric mean of 3 numbers, you multiply all 3 together and take the cube root of them. Okay, it's called geometric mean. Now, if you didn't know this before, you would still not realize. So why is it called geometric, right? You would still be wondering that. That's the meaning of geometric mean. Now, let me just tell you this. This is like additional knowledge. Okay, this is not in the syllabus. I'm just telling you what geometric mean means. Geometric mean. Say you have a rectangle whose side lengths are A and B. I'll take A and C. Okay, A and C. If I ask you the question, can you tell me the side length of a square? What is the side length of a square? Square, all sides equal, whose area is the same as this rectangle. What's the side length of a square whose area has the same area as this rectangle? How would you find it? Area of this rectangle is A times C. And this, now the square needs to have the same area, AC. And then how do you find the side length of the square? You have to square root AC, right? Because this area is AC. You get it by multiplying this times this. So side length would be, oops, sorry. Side length of the square would be square root of AC. So that number, this number is called the geometric mean of these two, because it's a geometric thing that is happening. Yes, Anita, that's right. Root AC. So similarly, if you have 3 numbers, A, B, C, 3 numbers, then you're thinking of a cuboid. Say you have a cuboid, 3 dimensions, A, B, and C. Height A, breadth B, and length C, suppose, right? And then if you ask the question, what's the side length of a cube? Meaning all sides same, cube. Whose volume is the same as this? What you get is a geometric mean of these 3. So volume of this is ABC, A times B times C, and this should have the same volume, A times B times C. but here, since the side lengths are all equal here, to find the side length, you have to cube root it. And so on, like, so it goes on, right? So that's why it is called geometric. So now you wrote, okay, shall we write under why geometric? You write again, there is an interesting relationship among any three consecutive terms of a geometric sequence. Did you write that already? I forgot. Let's write it here. So the two notes go in a similar manner. There is an interesting relationship among any three consecutive terms in a geometric sequence. And then you write A, B, C. This represent any three consecutive terms of a geometric sequence. And then you write B, I'll write in a different color. B is the geometric mean. Is the geometric mean of A and C. That means B is equal to A times C, AC, and square root of that. Okay. Okay, so that's it. Why they are called the way they are called. And then let's look at series. Okay. I will divide the page into two. Arithmetic. Geometric. And then subtopic, arithmetic series. That means we are now going to think what happens when you add the terms. Is there a formula that we can use to find the sum of any number of terms that we want? Okay. Arithmetic series. Here, geometric series. And under that first bullet point, now when you talk about series, as I said before, you can talk about the sum of a finite number. You understand, right? When I say do you understand what finite number means? You have an ending, like the sum of 10 terms, 100 terms. Okay, that's what finite means, as opposed to infinite. When you say infinite terms, no ending. You keep adding, keep adding, keep adding, keep adding. It goes on. You keep adding. So let's the first bullet point, finite. We are thinking of the sum of finite terms. Let's say finite series. Okay, I'll write finite series. But as I said before, strictly speaking, the word series is used if your summation is infinite. So there is nothing called finite series. Series is always infinite. Okay, but it's okay. Finite series. Okay, so what we are thinking here is, if you have a arithmetic sequence and you want to add, starting from the first term, you want to add all the terms up to a certain point. Is there a way that I can find this sum without actually adding one by one? Can I use like a formula? Is there a common formula that I can use for any arithmetic series? That's the question here. So here's what a finite series would look like. You are thinking of a plus, I'll use the U notation, U1 plus, I'm sorry, let me erase that. A or it doesn't matter, okay? But here I think the U notation would make better sense. But you can use A. Or shall we keep A? Yeah, it's okay. We'll keep A because we were using A now before. So A is same as U1 plus U2 plus U3. You're adding them now up to say some nth term, right? This is called what? Now we already learned this. What do we call this? Sn. Sum of n number of terms. Senitu. If all series are infinite, then is the notation is notations are not imaginary. In lower levels, we loosely use the term series to say to indicate any sum of any number of terms, because it's not like you're not majoring in mathematics, right? So it's okay, but strictly speaking, that word is used for infinite series. So when you should, the question you should ask me is, then what word is used when you're adding a finite number of terms? If they are not called series, what are they called? That's what you should have asked me. They are called partial sums. But just to keep things simple, we don't want to throw jargon at you and make things complicated. It's actually called a partial sum. Partial means you add up to a certain point. Partial. S10 is a partial sum of 10 terms. S infinity, that's the series, the whole thing. Okay, right. So this is Sn, and we are not learning the derivation of this formula. There is a formula for Sn, and you just have to learn it. So here's the Sn formula. If you want to find the sum of n terms of an arithmetic sequence, that means an arithmetic finite series, Sn, all you have to know is, here's what you need to know. If you're adding up to un, you have to know the first term, you have to know the last term. Last term means in the chunk that you're adding. In this case, un. You have to know that last term there. You have to know the first term in your series, the last term in your series, and the number of terms you're adding. So 3 information. You need to know n, how many terms am I adding? What's the first term? What's the last term in this string? Okay, if you know those 3 information, you can find Sn. So here goes the formula. N divided by 2. There is an interesting story behind this formula, but I have to, it's about, what's his name? Gauss. Have you heard of a mathematician called Gauss? He discovered this formula when he was like 12, 13 years old. So it's no magic here. But unfortunately, we can't spend a lot of time talking about it, because we have a syllabus to cover, unfortunately. Okay, so n divided by 2. I hope you learned it in school, maybe. N divided by 2 times a plus, that's the first term. As I said, what are the things you need to know? You need to know a, you need to know an, and you need to know n. How many terms you're adding? N. So n divided by 2, a plus un. This is your formula. You add these two and times by half of n. Okay, that's your formula. Since un is there, sometimes you have to, like, you can plug in the formula for un here, and you get another another version for Sn. Okay, it goes like, can you do it? Imagine, okay, if I replace this un with, what's a un formula? What is un equal to? A plus n minus 1 times d. If I put that here, a plus, if I replace this with a plus n minus 1d, you are going to get, So let's write that down to n over 2. A, this A and that A gives you 2A plus, let me put this as a square bracket because I am going to need another bracket here, n minus 1 times d. Okay. So that's like a different version of the same thing if you replace un with the un formula. Because now you have different set of information. That means you can find the sum of n terms when you know how many terms you're adding n, when you know the first term and the common difference. You don't have to know the last term. See, you don't have the last term in this formula. So that's another useful. All these formulas are given in your formula sheet. That's another thing I want to remind you. If I just show you. Right, arithmetic UN formula, geometric UN formula. These are the two formulas that we just wrote down. SN formula for arithmetic, SN. This is same as that. Okay, so they're all given, don't worry. But these will automatically stick in your head when you do a couple of questions. Right, we'll do a little example under this. Because I mean, we've been just writing. Let's do a little computation example. Example number 1. I will give you 2. Okay. Right. Find the sum of the first 20 terms of the sequence. Find the sum of the first 20 terms of the sequence. 1 comma, I'm giving you the sequence. 1 comma, 1 1/4 comma, 1 1/2 comma, ... Find the sum of the first 20 terms of this sequence. So 1 plus 1 1/4 plus 1 1/2 plus up to the 20th term. What's the total? How do we do this? Let's write what we know. Remember, we need A and we have A. A is 1. You don't have the last term. How many terms? We have n. How many terms are we adding? Because we need n and a. But whichever formula you use, you need n and a for both of them. So do we have them? We have a and we have n. How many terms we want? 20 terms. Then if you are to apply this formula, you also need that last term. That means in this case, 20th term. Do you have it? You don't have it. Then can we use this? Do we have D? To use this, we need D. We don't, but we can quickly find it. Because we are given the sequence. To find D, you only need 2 adjacent terms. You take a term and minus the previous term. What's the D here? What's D here? Yes, that's correct. Senitu, quarter or 0.25. Then you can use this formula. S what? S20 is equal to, okay, I'm using this formula, S20, my n is 20 now, is equal to 20 divided by 2, 2a, 2 times a, 2 times 1, 2, I'll write 2 times, plus, I'm just showing you everything, 20 minus 1, that's not 19 times 0.25. See what you get, tell me what you get.
Is it
Check with me.
7.5?
How much?
67.5?
Let's see. I will write it here. Can someone confirm? Yes, Seneca has gotten the same answer. It's correct. 67.5. S20 is 67.5. Okay. Let's do one more. I'll give you a different set of information for this one. Okay. Example 2. All this is happening in the arithmetic column. Right? Find the sum of the sequence. No, sorry. Find the following sum. That's it. Find the following sum. 8 plus 6 plus 4 plus ... plus. So in the middle there are some terms. We don't know what they are. Plus minus 32. Find this sum. Now, actually, in the first example, we forgot to do something. We took it for granted that this sequence is arithmetic. Did you check whether it is arithmetic? You can't use this formula to any other. You can only use this formula to an arithmetic series if you are adding the numbers of an arithmetic sequence. Did you check? It is arithmetic, okay? So again here, see whether these numbers, do they follow an arithmetic sequence? Is there a common difference? You have to check that now. At the exam, if you get a random sequence, for you to know which formula to use, you have to first identify whether it's an arithmetic thing or geometric thing, okay? So what do we know here? I know A. I know N. A and N, definitely you should know to use the SN formula. A and N are, you have to know them, but whichever the formula you use, N and A are there in the two formulas. Then if you also have last term, you can go for that formula. If you have D, you can go for this formula. So first thing to see is whether do I know A and N? Do I know N?
Teacher, we should find it.
You should find it. Good. We don't know N, but we know U. So let's call this UN. I don't know which number term that is. I don't know whether that is the 10th term or the 20th term or the 100th term. So I know UN is minus 32. I have to find N. Do I have D? I have D. I have D. 6 minus 8 minus 2. Okay. So if you look at the formula, I have A, I have N, I don't have this. I have A, I have N. Sorry, I don't have N. I don't have N. I don't have N. I have A, I don't have UN. For this formula, I have A, I don't have N, I have D. So I can't apply either of these. Right? So you need more information. You need to find, let's find N. How do you find N? If you know UN, because you also know D, you can find the UN formula. Let's apply the UN formula for this. What's the UN formula? UN is equal to A plus N minus 1 times D. Now I know that UN is minus 32.
Teacher?
Yes, Akitmi?
It was lagging for a moment.
Oh, I'm sorry. Did you miss something that I said?
No, teacher.
Okay. Okay, so I'm just trying to find N now. I'm going to use the UN formula and apply it for this UN that I know. So here's your UN formula. I know my nth term. I don't know which term that is. Whatever the term is minus 32. A is 8 plus, I don't know what N is. I know D. N minus 1 times minus 2. I can find N from this. Yes, Senithu, you are right. Senithu, you have missed, right? 8 plus. Isn't it? Yes. Right. So let's solve this. Can you solve? No, you have to solve it. Okay. You solve this and tell me what n is. What's n? If the answer is negative, no. If the answer is negative, it's negative. For n, you can't get a negative number for n, because n means n has to be a positive number. It's the position of the term. It goes first, second, third, 1, 2, 3, 4. You can't get a negative answer for n. If you do now, I don't think you get a negative number here. Like in certain cases, if, for example, if you are solving a quadratic equation of n, if you get a negative answer, you reject it because it can't be a. Okay. So what is n?
It is 21.
How much?
21.
21. Is that right? Okay. Then now you have all the information you need. You have n, you have a, you have more than enough information. You can use your choice, either of these, right? So apply any one that you like, because you have enough information to apply either of those two formulas, and tell me what S21 is equal to. So I will just write it here. What is S21 equal to? You're finding S21, sum of 21 terms, S21.
Yes, I get minus 252.
Minus 252.
52. Yes.
Okay. Now, would you have a worry that you got a minus answer? Can the sum be a minus answer? It can, right? I'm just asking you, like, now for n you can't get a minus answer. If you do get a minus answer, you say I reject it, because it's the position of the term in the sequence. That can't be a negative number. But the sum of your terms can be negative. So that is, you shouldn't keep any doubt when you get a negative answer, because if your numbers are, but I am thinking, yeah, can we? I feel like it's too big a negative number. Is this right? Minus 252. Right, 21 terms now. Do you see now immediately, very soon, the terms start to become negative here because you're subtracting a 2 now. So many of the terms in this sequence are negative terms. So when you add them, you're going to get a negative number. Can someone verify this answer? Minus 252. Minus 252. Good. Okay. We have only 10 minutes left. Let's quickly try to go to our geometric column back here. So first, put the first bullet point. Now make a note. We only discussed finite series. What about infinite under arithmetic? We'll get to that after we do finite series for geometry. Okay, so first bullet point under this, under geometric series, finite geometric series. So finite series. And again, let's quickly do this now. This should be, we should be able to do this quite fast now because it's the same thing. You can just look at this side and right. So we are doing the same thing. Now we are talking about a geometric sequence and we are adding the terms up. So you start with your A, U2, U3 plus dot 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 up to some term. It's a finite series up to a certain term. We are trying to find Sn for a geometric. So it's a geometric series. Right? And unlike in an arithmetic series, the formula for sum of n number of terms in a geometric series is quite simple. You only need to know three information. You have to know the first term. You have to know that. You have to know how many terms you are adding, n you have to know. But you don't have to know that last term. Instead, you should know what R is, the common ratio. Okay, so here's the formula. Sn is equal to A times 1 minus R to the power of n divided by 1 minus R. A times 1 minus R to the power of n. One minus R. Here, let's make a little note here. R cannot be equal to something. Look at the formula and tell me. Because if R is equal to a certain number, this formula makes no sense. What R cannot be equal to? Look at the formula. Very good. Why, Senitha? Why R cannot be equal to 1? What's the problem if R is 1? This formula is not going to work if R is 1. The denominator becomes 0. If R is 1, 1 minus 1, denominator becomes 0. The formula gives you an error. It's not defined. Okay. So think of a geometric series where R is 1. What does that mean? Same number repeats. Like if you start with 5, comma, 5, comma, 5, comma, 5, comma, 5, comma. That's a geometric series, a sequence. You're multiplying by 1 each time. So it's the same term, repeating same term. That is a geometric sequence, but you can't find the sum of a certain number of terms in that sequence using this formula. Okay, it won't work. Right, shall we do a quick example? One example is enough because that's a simple formula. Find the sum of the first 10 terms in the following sequence. Find the sum of the first 10 terms of the following sequence. 5, comma, we had this sequence before. 5, comma, 10, comma, 20, comma, 40, comma, dot, dot, dot. Now again, you will take it for granted it is geometric because it's an example coming under geometric. But in the exam, you have to check to see. Right? It is a geometric sequence. This sequence is a geometric sequence. We are asked to add the terms. So that's a series. 10 terms. So let's see what we know. We have to know A, and we know A. We have to know R. We have R. A simple matter of dividing 10 by 5 as half. Do we know N? Yes, 10 terms. Can you apply the formula? S10 is equal to 5 times 1 minus half to the power of 10 divided by 1 minus half. See what you get.
Teacher,
Yes, Akitni?
isn't R supposed to be small?
Oh, I'm sorry, R is 2. Thank you, Akitni. R is 2, 10 divided by 5, any term divided by the previous. These are being multiplied by 2, my mistake. It's 2. Thank you, Akitni. So 1 minus 2. 2 to the power of 10. You're going to get a big answer. Oh. You will get a huge answer. Would your calculator, can your calculator handle it? It might be too big an answer. Come with that.
I get Aki yellow corn and throw it.
What? What is that?
The yellow corn,
The yellow one?
crayon,
The crayon,
I
yes?
throw it where I wanted them.
Ah. Do you get a huge answer?
Yes, teacher.
Yes, no?
Five.
Reduce the number to 5. 5 terms.
No, only 4 terms. 5,150.
Is that 10 terms?
Yeah.
Ah, that's not bad. Okay. 5,000?
115.
115 or 50?
One.
15. Right, okay. Ah, that's not too bad. I thought, because 2 to the power of 10 itself is like how much? Okay, that's not too bad. Right. Okay. So was that clear? Then we have to do, we don't have time to start that, but put the next bullet point. So under, in your 2 columns, 2 parallel bullet points under series, arithmetic series and geometric series, infinite series, infinite series. And I will leave you with this thought. Now, I know that you already have learned it in school, so it will be, but okay, I want you to, for a moment, forget what you know that you learned in school about infinite series. And I want you to think fresh in your mind about the possibility of adding infinitely many numbers. Is that even possible? What do you think? Can you, let's go back, let's stop sharing this. Oops. Okay. What do you think about, say I give you an infinite sequence. It doesn't matter arithmetic or geometry. Okay. You have an infinite number of numbers and I ask you to add them. And then give me the answer. Does it sound like something possible to do?
No.
Huh? Yes?
No.
No, right? But others, what do you think? But for certain series, arithmetic series, you can't, as you said, you can't add and finish. So it's not possible to find. I mean, the sum doesn't give you a finite number. But for certain geometric sequences, you can add It doesn't mean that you will sit and take a calculator and add each term. That's not how you do it. There is a way to find the answer. When you add all of the terms, the infinitely many terms, what the answer is, there is a way to find it, which is an amazing thing to think when you think about it. How is that even possible, right? So we will look at that next time. Then we